our last speaker is Trin from Electrical Engineering Binary, Internet of Things at Wentworth Institute of Technology. And then, sorry.
I can do that part.
I almost about do-it-yourself remote access robot car. So let's welcome Trin.
Good afternoon, everyone. So my name is Trin, an electrical engineering student here, and I'm so happy to be here this year again to present my project. Today I'm bringing my project here with the name is Do-It-Yourself Remote Access Robot Car. So this project, I fortunately worked with Professor Piling and get her advisement for this one. So in my presentation, I will go first to the introduction, which been talking to this idea and the challenge I face with, the basis knowledge that you need to do this project. Then the next one is the hardware design. I will show you the layer in my car and also what components that I use for this car. The next one is the electrical circuit design. This part will be the one I spend more time to explain to you what challenge I have, and then that challenge that affect to the way I design my electrical circuit design. And at the software design, I also show you how the software gonna work with my car, and also do some demonstration and resort to you. The last one is just for future improvements. So let's talk about the introduction. So the idea is robot cars always get attention for engineering and hobbyists. And for me, electrical engineering also with a minor in IoT, it even more attracted me to get this project. One more thing is, I'm kind of person that kind of cheap. I want to see what I can do with the components that I already have with my other projects. So the goal of this project, I try to limit the minimum that the components I will buy for this project. So for that, because I use the components that I already have, it makes the mismatch the component use. So the mismatch also, it makes the challenge in the hardware design and also software design. And the most challenge for the hardware design is the power supply for the car. And the software design is the user interface, because some library not support for Arduino, that one I use. So my solution for that one, I'm gonna explain detail for the next couple of slides. And the knowledge to do this one is you need to have some basic knowledge in electronic troubleshooting, soldering, and also you need some basic knowledge in C and Python programming languages. Outside of that, you need to familiar, it's very basic one, like how you do the command line in Windows and also in Linux, because Raspberry Pi they use Linux system. This is the layer of my car. So I built my car on 2 plastic layers, and this is how it looks like. Right here, it divided 3 parts. The bottom part, that's mostly I just store the motors and the wheels. The second part is my power supply. And the top part, that's the control center. And the reason I put in the top, just for me, it's easier to modify if I need it. And, all right, let's see a closer look with the car. The Raspberry Pi connect with the Arduino. Raspberry Pi will be actually the brand of the car. So I will get access into Raspberry Pi. From that, I will be able to communicate with the Arduino, how Arduino to control the motor to make the car run. And also the cameras that's connected to Raspberry Pi as an input to send the real-time video streaming to my desktop over there. So from that, I can see what the car can see. And for example, I can bring my car outside of the walkway and I still see what's going on in outside. And I can make them run to right, left. Also, I can make them to take a picture, send a picture back to my laptop, change the file name, and then send it back to the Raspberry Pi. And the next one, just the power bank I did talk about. About electrical circuit design, I use portable charger in my project. The reason for that, because portable chargers have a large capacity. Also, they can provide a stable voltage for a long time. So that's an idea for me to use portable charger instead of the 9 voltage battery. However, the portable charger is not designed for low current circuits like Arduino. And because of that, the advantage feature in portable charger, it becomes disadvantage for my circuit because the auto switch off feature. So what is auto switch off feature? And why I need to care about that one? To answer those questions, let's do very quick about how the portable charger works. Portable charger, usually it provides 5 voltage out for a tablet device. However, the internal voltage in portable chargers is only 3.7 voltage. To be able to provide 5 voltage out, they need the step-up converter or boost converter to bring up the voltage to 5 voltage out at the output. And for the boost converter, the drawback is that one always draw current powers out. So you don't have any load outside, but your portable charger still be drained during the time. And to stop that issue, they have their own auto switch off feature, which is make the portable charger cut off the power when nothing going on outside or the currents outside, the current draw outside is below the current threshold that they set for this portable charger. Depend on the technology they use, the current threshold, it could be from 50 to 200 milliampere. And for this one, it's around 90 milliampere that we cut off. So for that reason, it will make my car, when my car at the idle mode, waiting for the command, they do nothing and they use very low current. And that's why it makes the portable charger think that there's nothing going on outside, they cut off the power. So my car lost the power. And to solve that problem, I had to make an external circuit that makes sure it draws the current out higher than the current threshold to let the portable charger know that, hey, still something going on outside and provide the power for my car. And this is the external circuits that I use the 330 ohm resistor to draw the current out. So this is the beginning, the first electrical circuit that I designed, and the registers did a good job to keep the power supply.
How many amp hours does your supply have?
So the big power portable charger is 30,800 milliamp per hour.
30 amp hours? Okay.
Yeah, and then I have a small one is 10,000, which I'll explain later after I do the demonstration.
Okay.
Yeah, so for now, I'm just talk about just one portable charger for my first design.
Mm-hmm.
So this one is successful to keep the power on. However, I experienced that. So this one is how the external circuits inside entire electrical circuits in my car that I have Raspberry Pi connected Arduino through serial connection. And then from Raspberry Pi, I have a fan to cool down Raspberry Pi 4, camera connected to Raspberry Pi. Register 330 ohm in parallel with Arduino, in parallel with Raspberry Pi. And I also have capacitors here. The reason I have capacitors here because I experienced my Raspberry Pi, it didn't run stable. Sometimes it re-put. And at first I thought because the wheel, it draws a lot of current sometimes, so it doesn't have enough current to run into Raspberry Pi. That's why capacitors here. In the case that they draw too much current, it can provide more current and power for Raspberry Pi. However, this one, it couldn't do the job because Raspberry Pi, the 4B, they draw a lot of powers. So this design fell, and I had to find other way. As you say right here, that's the issue. Yeah. So we also my car running very quick. So the solution for that is I add an external power supply, which is here. I have 2 power supply here. I use this one, the smaller one, the smaller capacity one, to provide the power for Raspberry Pi 4 Arduino and the cameras only, because it have higher current.
What about the weight of the batteries? How does that figure into the weight of the batteries?
The weight, so in total right now, the car is about 1.7 pounds for my car. It's kind of heavy. I can answer later because I have limited time.
Go ahead.
Okay,
Sorry.
sure. So this is the previous one, and this is the new one. The new ones, I replaced the 330 register to the fan because the fan, it can draw the current, it's 0.2 ampere. It's high enough to keep the power supply going on still. But also, in this one, I use additional power supply connects here, and the car run very stable, have enough power for them. So, about the software, that's it, those software and application that I use. I also use Sublime Text as programming language text editor for that too. So when I use my laptop, I connect the Raspberry Pi through ASEE-NE communication, which is use Wi-Fi. And from that, the Raspberry Pi gonna be wired, connect with the cameras and Arduino. Arduino gonna connect with all those wheels. For cameras, it act like input and output to send the video stream to the Raspberry Pi and to my desktop. Also, when I send a text to the Raspberry Pi to have camera take a picture, so they act like an output too. And the challenge for software is, as I say, the user interface, some library like the keyboard for Arduino, they don't support for Arduino Mega, so I couldn't use the arrow key. I had to replace with the number, which it makes it harder for user to use. And also serial communication, the data they send not in the home block. So sometimes if I type so fast, they don't send all the data to Raspberry Pi at that point. So it makes my programming mess up. Application performance, some application like lip camera that I use, or some coding for the camera, it doesn't work in virtual environments. So when you have Raspberry Pi connect to the monitor, it's work, but for virtual environment, it's not working. And this is demonstration how it look like in my car. This is the camera, that's the user interface that I make. I use Arduino IDE, but also right now I can use Arduino in the command line, so I don't have to open Arduino IDE application. For the visual, power supply, what I experience here is the power that's used for Raspberry Pi Arduino, it almost double the powers that they use for the movement. And which I'm surprised because I thought the motor are gonna use a lot of powers instead of the Raspberry Pi. And for the time running, so this is the combined all the movement that I use regular one. So for this one, it will take up to 13 hours to, the car will be able to run up to 13 hours for normal activity for the 10,000 milliampere. All right. And for future improvements, so at first I want to make the car lighter. And second thing is I want to do the Python script that can do everything instead of I enter the code every single time. And the third thing is for future that I want to do my car to be self-driving without my supervisor anymore. So the car will be able to detect the stop sign, traffic sign, and also keep the lane. So when I can turn it on, it will know where to go and it can control itself. All right, so I think that's all for my presentation. Any questions? If you have time, I can do a very funny demonstration for 2 minutes.
Can we see demonstration?
Sure.
Thank you.
So this is the car. So that's demonstration. I need to connect to my laptop. It's off. Sorry. Turn it, that's up, turn off.
So quick questions, Mark?
Yeah, I can go fraction first.
So, have you done any studies in terms of how much the drain on the battery relative to the weight? I know you're aware of it because you said you were gonna, in the future, that's what you wanna make it lighter. But,
Yeah, so the weight of the car is actually affecting to how long it can last to,
Yeah.
and also the condition of the floor. So I had to change different kind of wheel
Yeah.
because for the rock, the one when I did it, it's on the wood floor. They make it, for example, if I make the car turn for 700 millisecond, they can make 180 degree. But for the rock floor, right now, they only can make 100 or 90 degree only. So it will add into that one. I also experienced that the motor will be hotter for the rock surface too. I use a lot of application here, but everything very simple. Like Python, you just care about serial communication. ASEE-NE have a lot of tutorial online. I have everything ready. Just sort of give me a second. So now I can do everything that you see how I do it. At first I use remote desktop. I connect with the IP address I already know from my school. So now I can access into Raspberry Pi. Because I need full password. I try to keep it secret, but then now I have to do it. Like it's meant to be. Okay, so also the action of the car is depend a lot on the Wi-Fi connection. When it's slow, it takes very long time to get in. I think this one is slow. All right. Okay.
If
Good.
you want to see, you can closer, come closer and then stand up and you can see it.
Okay. So I also have created a Python code that I can control the focus of the car. So right now you see something over there that I already set up. And let's see. Do you think so? Alright. I think this should be good. Yeah. So the car right now can see, and on the right side, top right, that's my Arduino inside the command line. I didn't use the Arduino IDE. For that, I will do direction with the number. So now I want to go backward, number 2. And then I want it to run for about 3 seconds. So it's gonna be milliseconds. So it happened like that because one leg was broken. Last week when I helped school to do demonstration, there was one family, they loved my car too much and they dropped my car from the table.
So that's one of your future improvements.
It's all broken. So it connect now, it's just the power to that wheel is not strong enough to make the same power 2 sides. By the way, so for the wheel, it's 4-wheel, but I didn't make it 4-wheel drive because the motor driver controllers is only 2 channel only. So I connect them in parallel for each side. And by for example, the right side slower speed and the right side faster speed, I can make it turn right. And same way with the left side. All right, I feel bad I do that. So let me do number 4, which is turn left for 900 milliseconds. You see it? And then you see the live stream is the quality is pretty good. So for that, I can make the car. Let me try number 8 one more time. Jason, make sure you stop it if you go too bad. Okay, so it goes straight, good. It's just the backwards is not good. So now I do number 6 to turn right for. So because that wheel is quicker, so I'm gonna do high longer second. So I do 900. You see it? And then from that, because the lead camera is not support for the remote control. So if I want to take a picture, I have to go out the environment, which is I use Windows PowerShell in my laptop. Oh, yeah, Windows PowerShell. Right here. The command line, and I have the code. Let me open my code very quick. Nope. So I want to show very quick, there's no thing here in my folder test. See, you see nothing here? So now let me make it take a picture. To be able to take a picture, we have to turn off the cameras because they can't do 2 jobs at once. So I turn off the live stream right now. Sorry, sorry, but my performance is back from the internet connection. Alright, so I turn them off. And now I go my PowerShell, which I'm gonna use my LibCam camera application. Oh, for that, we have to use LibCam because AduCam have different applications that they can use for the camera. So before Raspberry Pi 2 or 3 and previous one, you can use Rust, still something like that. It's the same. It just they have lib in the beginning of the code. So at first, I want to connect into the Pi. I use SH. That's in my username and IP address. Alright, so now to connect into, it's asking for a password. Once connect to, I can start to use the code. I can copy. Okay. So the code basically just the command. Ask them to take a picture, that's the location and the file name that I made for. Right here it says still captured image received. And then let's check in the Raspberry Pi at the test. Yep, see, we can see that image right now. See you, Jason. Right. And then one more thing that I want to do automation, so I create a Python script. So that Python script out there, and then I use this application to open. It's just nicer color for me to look at. That's my Python script. I connect to the Raspberry Pi. This is location I wanted to do, and change the file name so you know that I already draw the file down, and then I put it back to the Raspberry Pi. So I just change the name test 1 and test 2. They connect the Raspberry Pi, then they use the SCP application to copy the file up and down. And that's on, so let me print it. So I also use that in the PowerShell. I open another PowerShell. Okay, I need to go to the location that I have that Python script, which is, if I don't remember, okay. Yeah, and then I run Python code for ASEE-NE So that one gonna be automatically connect to the Pi, wrap the file down, change the name, and then drop the file up. Okay, let's see.
No, you need to delete it.
Huh?
You need to delete
The
the.
original file.
Oh, yeah. So where did I set the oh yeah. I tested earlier. It wrapped Jason down. Alright, we do one more time. Alright, so now we see test 1 and test 2. We go to Raspberry Pi and see it. It shows test 1 and test 2. This should be the same. Just change the file name. Right, so that's all for my demonstration. Hopefully you feel like you will sell by yourself.
Good job.
Thank you.
Okay.
Want to keep your picture?
Okay, thank you so much for all the speakers and audience joining our session. And then there were 4 excellent presentations in this session. And I'm so proud of all of you. And how many of you were first time presentation to conference? Oh, 3 of you. And second time for Jim.
Yeah, me and Jason was in this conference last year.
Oh, okay, sounds good. thank you. And then we'll conclude this session very successfully, but can we have a group photo together to celebrate the session with everyone, audience and speakers and everyone.